Let's take a look at some tools that help us organize our code in memory, and then we'll actually be able to write a program using this stuff. So first let's look at the org function, which allows us to store a block of code at a certain part of memory. So let's say I wanted to store some code at memory location 800 and beyond, basically. So you go org and then your $sign to show that's a memory location 800. Now, any code that you write after this, you will be able to store it at memory location 800 to start, and then you keep on going here. So then 801 will store the next line. Say your first line was the load AA number 7. Your next line will be, say, load AA number 8. That will store that instruction into here, and it will just keep on going. This can also be called a memory map, what I'm drawing here. It basically just shows the memory and the different things in its and the different things stored in those locations. Right? So that's basically the org function. Next is defining a constant. Now, here I just wrote to use dB or dW, but in reality you can use whatever you want. Not whatever you want. There's a lot more that you can use than just dB and dW. So, say I wanted to define a byte, which means it only takes up a byte of space. I have to use the dB function. dW is just defining a word. So this is only 8 bits, right? This one is actually 16 bits. So that they just vary on the size. So there's many other different types of things that take up a different types of space. So like you can read up again on it in different documentation, but for now we'll just look at these two, as they're like one of the more common ones. So say we wanted to define the constant C. So to do that, we'd have to write C dB and then whatever value we want. So 5. So now wherever, say we organize this at memory location 10, then at memory location 10, this will now store 05. As this is also a decimal number, it will also get converted into hexadecimal. Have a understanding on how programs work. Let's try writing a program. So I'm gonna start off by organizing some constants. So I'm gonna organize these constants at memory location 800. Now, say I wanted to first define the constant XX. Remember, we can't just use X because we already have a register X. So I wanted to find the constant X as a byte, and I want to define it as the number 5. Now YY is also I also want to define that as a constant and as the number 10. So these are my two constants that I'm going to use. Cool. So now I want to write some instructions that will manipulate these numbers. So I'm going to organize my instruction at memory location 1000. And now I want to load my XX value into accumulator A. So now it will take whatever XX is and move it into accumulator A. Now let's say I wanted to, here's another new instruction though, called add A. So now it will add whatever I write here. So say I wanted to add my 10 to it, I would have to write add YY. So now it will take YY, which is 10, and add it to XX, which is loaded inside A, and so it will add 10 to 5, and we will get 15, right? Now we're going to store this back into another new memory location. We know that XX is stored at memory location 800, YY is stored at memory location 801, so let's store this one in memory location 802. So now we want to end our program. Every program must end with these three letters. We'll get more into what this is, and then finally it must also have a dot end. This is how you write a full program. So I want to just quickly write out a memory map for this. So at 800, 801, and 802. So at 800 we have the number 05. At 801 we have the number 10. But since in hex it's 10 is actually equal to A, we have to write out 0A here. And now we added 5 plus 10. 5 plus 10 in hex is equal to F, which is 15. So we write down 0F here. And that's how we basically write a program. So we'll go over this in a little more detail in the tutorial video. Thanks for watching. We'll see you next time.